Good evening. Today we are going to see problem that is shear reinforcement. So we have unit 3. Now we have seen already. So we have this nominal shear reinforcement actually is not required, but though it is not required as per IS code provision, but we have to provide minimum shear reinforcement to tie the rods, that is main reinforcement and anchor bars. So this is VUC by 2, this is VUC plus VUR minimum, and then this is VUD. So this VU we have at center of support. This value is at center of support, and therefore we are going to consider this value, and that is equal to V by 2 plus D, and that we will get as VUD. And these two formulas we have seen in IS code, that is for design reinforcement and that is for minimum shear reinforcement. Now this is transverse reinforcement, which is actually for torsion. So now we have this problem. A reinforced concrete beam 250 mm wide and 400 mm effective depth is subjected to a shear force of 45 kN at quarter span. The tensile reinforcement at support is 0.5%. Design the shear reinforcement at this section. So support we have 0.5%. So at quarter span, definitely we have same value. So now we have to solve this, and B part we have support shear is given 75 kN. And for both we have to find out spacing of 6 mm diameter stirrups. So now we have to use M20 and FE 250. So we will start. Given data we have B is given 250, D is 400, and percentage we have 0.5%. FCK is given 20, FY we have 250. Vmax we have 45 kilonewton. This is A part, and B part we have Vmax 75. I am writing Vmax, not VU. So VU we have to find out. So design shear VUD in first case 1.5 into 45, 67.5 kilonewton. Then if we will go to table 19, IS 456, and percentage we have 0.5%. For this, if we will see the value of tau UC, then we have tau UC as 0.48 Newton per mm square. Then shear resisted by concrete, we know this formula tau UC B into D. Tau UC we have calculated, we have taken from table 19.48 B 250 into 400, which is effective depth. And this is 1000 because this total value we have in Newton, and to make it in kilonewton, we have into 10 raised to minus 3, gives us 45 kilonewton, that is VUC, which is less than 67.5 kilonewton. So we have to provide shear reinforcement. Now shear resistance of minimum stirrups. Now we have seen formula, that is SV, which is equal to 0.87 FY ASV upon 0.4 B. Now we are going to consider SV as D and 0.87 FY ASE, that is VU as V minimum, and that we are going to say as 0.4 B into D. Now 0.4 into D, we will substitute the values. We will get it as 0.4 B into D, and we will get it as 40 kilonewtons. Now we will check VU SV minimum plus VU, and we will get this value, that is 88 kilonewton, and this value that is greater than 67.5 kilonewton. That means minimum shear reinforcement is sufficient for the given shear force, or we can say at quarter span. So we will assume 6 mm two-legged stirrups of grade FE 250. So two-legged stirrups means, if we will see, then we have these stirrups. So we have, this will be our anchor bar, and we have main bars, that is at tension side, and we have this as stirrup. So now you can see this. So we have, this will be two-legged. This one leg, when you will take section, so we have one leg over here, another leg over here. So two-legged, and area we are considering 28. So it is 28 point something. So we are taking 28. So into 256 mm square. And then we know formula SV is 0.87 Fy SV upon zero point 4 V B, and from this we will get this value as 121.8 millimeters. Then according to IS code, this SV should be less than or equal to 300 mm or 0.75 into D. Now we have D that is 400. So we have 0.75 into 400. It comes again 300. And then we have SV 121.8. So minimum of the three we have to consider, and therefore we will provide two leg 6 mm diameter two-legged stirrups at 120 mm center to center. So this is for your A part. Now if we will go to B part, which is shear force at end, which we have 75 kilonewton, and we have design shear now VUD, which is equal to 1.5 into 75, and that will gives us 112.5 kilonewton. Now in the same problem we have calculated VUC, from which this we got from tau UC B into D, and tau UC we got 0.48, B we have 250, and D we have 400, and from this we got this value as 48 kilonewton. Now shear resistance of minimum stirrups. So this also we have calculated, which we got value 40 kilonewton, and then we got this value VUR minimum equal to VUC plus VUSCB minimum, and we got this value as 88 kilonewtons. Now this 88 kilonewton is greater than 67.5, but it is less than 112.5 kilonewton. This is of last problem. So this problem we have this value 112.5 kilonewton, and therefore we have to design shear reinforcement. So now minimum we have already calculated in last one. Now here we will go for design. So which is VUS. Now we have VUD minus VUC. VUD we have 112.5 minus VUC we have calculated, which is 48, gives me VUS 64.5 kilonewtons. Now SV we can find. So we are going to get SV 0.87 FISVD upon VUS. And from this we will get this value as 75.53 millimeters. And knowing this value, we are in position to get the spacing. And now we have this as provide 6 mm diameter two-legged stirrups at 75 mm center to center. Now again two criteria as we have, that is 300 mm, which is second criteria, and we have third criteria, which is 0.75D, and this also comes 300 mm. And we have to take a minimum of 75.53, then 300, and then 300. So we have 75. So you can go 70. It is not essential always. It should be multiple of 0 or multiple of 5. Here you can take 70, or you can go for 75 millimeter center to center. So if we increase diameter, automatically your spacing will be increased. Or if you have FYSD bar, then also your spacing will be increased. But we have given 6 mm and that is 250. So we have to go for the same. So this is all about your problem that is related with your shear, where when we have values are given. So we will stop here only. Thank you.